Hello again. Today is May 4th, Tuesday. May the 4th be with you, all of the Star Wars nerds out there, like myself. For self-start today, students are either working on yesterday's worksheet, it was on the back of the Jeopardy paper, or those people that are done are trying this challenge question. So there are two elevators in a skyscraper. Elevator number 1 starts on the 10th floor. So 10th floor. The elevator goes down 15 floors, so it goes down, that would be a negative 15. It goes up 19 floors. It goes down 12 floors, that would be a negative 12, and up 1 floor. So that's the first one. Second elevator starts in the parking garage 3 floors below the surface, so it starts at a negative 3. The elevator descends, that means goes down 1 floor. So that's a negative 1. Ascends 7 floors, that means goes up 7. Ascends 13, so it goes up 13. And descends 9 floors. That's a negative 9. And ascends 7 floors. So now we've gotten our expressions written. So now it's just a matter of plugging them into our calculator. So elevator number 1, we're going to do 10 plus negative 15 plus 19 plus negative 12 plus 1. So the current position of this new first elevator is 3. So it's on the 3rd floor. Second elevator, we start off with a negative 3 plus a negative 1 plus 7 plus 13 plus a negative 9 plus 7. And that elevator is currently, looks like, on the 14th floor. So again, may the 4th be with you. So here's your Star Wars jokes just because it is May the 4th. How does Wicket get around Endor? He walks. He walks. Where did Luke get his bionic hand? Well, he actually got it at a second-hand store. What do you call an invisible droid? That would be C-3PO. And last one, what did Obi-Wan tell Luke when his young apprentice was having a difficult time using chopsticks at the Chinese restaurant? Use the forks, Luke. Yeah, if you don't get any of those, that's okay. If you're a Star Wars nerd, you're probably laughing. As far as information goes, just a reminder that May 21st is the deadline to turn in late work. Nothing will be accepted after that date, so that's a little bit more than 2 weeks away. Get it going. Seems like just yesterday we said we had a month left, so now we're down to almost 2 weeks. So, while we are not taking late work after May 21st, you can still fix any feedbacks, though, up until June 1st. So if you have some feedback retakes or corrections that need to be made, you have until June 1st on that one. For the individuals who have saved up homework passes, you are welcome to use them at any time. You're welcome to use them for missing assignments if you want. All you have to do is just staple it to a worksheet and then turn it in with your weekly packets. Those people that are saving them, the store to use them to buy things will be open on Friday, May 28th. We'll have things like candy bars and sodas and knickknacks and stuff like that you can buy. So for today, we're going to have students check their grades, and we're going to be reviewing expressions. So with expressions, we're going to be doing things like combining like terms. We're going to be talking about real life expressions, factoring, and distributing. So we talk about combining like terms. When we combine like terms, we're looking for things that are similar. So things that have the same variable or numbers that don't have any variable at all, stuff like that. When we do it, we put a shape around the things that are similar and we include the signs in front. So if I look at this, I have a negative 2a plus 3 plus 5a. I can combine the negative 2a and the 5a because they both have the same variable. So I'm going to put a shape around the negative 2a and the 5a, but I'm going to include the plus sign in front. So negative 2a and 5a's is going to give me 3a. And then I'm going to bring down the plus 3. And we got it right. So when we start looking at a little bit more complex ones, typically parentheses throw people off. So we can still do PEMDAS with it though if we want to. We want to do things inside parentheses. Well, I can't combine those because that's an X and that's a Y. And I can't combine those because that's an X and that one doesn't have anything. So can't do that. So now we're just looking for things that we can combine. So I can combine my 5x and my 2x. So 5x and 2x is going to give me 7x. I can't combine the y with anything, so I'm going to bring that down. And I can't combine the negative 3 with anything, so I'm going to bring that down. And that right there is as simplified as it can go. 7x plus y plus negative 3. We're right. As far as real life expression goes, this is something that we talked an awful lot about, how to set them up. There's two types of expressions that we'll set up. There's a numeric expression and an algebraic expression. A numeric expression is when everything has been given to you and no variables are needed. So if we look at our expression here, you'll notice there's no variables, there's no letters. So that's a numeric expression. An algebraic expression is something's missing and you have to have a variable. So in this case, I see a variable right there. So that would be an algebraic expression. So we're going to be using those here in the next couple slides. You're going to go see the new Cruella movie in theaters. You need to buy a ticket to get in and want to get popcorn and a drink and candy. How much money will you spend in total? So it gives me the prices. A movie ticket is $8, popcorn is $6.25, soda is $4.75, and candy is $3. So it says I need to buy a ticket. That would be $8. And want to get popcorn. Popcorn is $6.25. And a drink, which is $4.75. Remember, the word and typically means to add. And candy. And popcorn. And soda. And candy. Oh my heavens. Okay, that's going to be one full person. And the candy is $3. So how much will you spend in total? Well, I have all of my information available, so I can go ahead and combine like terms. So I'm going to go ahead and put this into my calculator. 8 plus 6.25 plus 4.75 plus 3 gives me an answer of 22. So with a numeric expression, when there's no variables involved, I can simplify it and come up with an answer. So what if we were going to pay for a friend? How much will it cost for 2 people to get all of that? Well, that's just like saying I need 2 tickets, so tickets were $8. And I'm going to need 2 popcorns. And I'm going to need 2 drinks. And I'm going to need 2 boxes of candy. So notice what happens. So I can multiply 2 by everything, or I can do 2 and then in parentheses put out what they're going to need for each one. So that's another way to do it. Or you can just list it out. 8 plus 8 plus 6.25. And this is really hard with the mouse, but we're going to try it anyways. Plus 4.75 plus 4.75 plus 3 plus 3. So any of these would be correct because I could get 2 tickets, 2 popcorns, 2 drinks, 2 candies. Or I can say that 2 people are each going to need all of those. Or I could just say I need a ticket and a popcorn and a popcorn and a drink and a drink and a candy and a candy. For a family of 5, well, I could do all of that. I could do 5 times 8 plus 5 times, and so on and so forth. I prefer to keep it easy, and I just prefer to do 5 people each need a ticket, and popcorn, and a drink, and candy. Or I could put 8 plus 8 plus 8 plus 8 plus 8, and I could do that 5 times, and then 6.25, I could do that 5 times, but that would take forever. So these right here could be considered numerical expressions because there's no variables involved. However, with an algebraic expression, it looks something like this. Bob bought 5 books for X dollars each and a DVD for $12. Write an expression for how much money he spent. Well, what do we know? We know we got 5 books. We know we got a DVD for 12. What do we not know? We don't know the cost of the books. And we can use any variable we want for that. So I'm going to use X. So now we need to write it. So 5 books. I see the word and a DVD. And then I see the word each. So it says 5 books for X dollars each. So each means to multiply. So that means I'm going to put my X with my 5 because it's 5 books and the X represents the cost of the books. It has nothing to do with the DVD. So this right here, this would be an algebraic expression. There's nothing for me to solve because it's an expression. And I can't combine those because this one has a variable and this one doesn't. So I'm done. Now, factoring expressions, this was the next one that we talked about. This is probably the one that confused the most people. When I'm factoring expression, we need to find the GCF, the greatest common factor. So factors of 8 would be 1 and 8, or 2 and 4. Factors of 12 would be 1 and 12, 2 and 6, and 3 and 4. So the biggest number that they have in common looks like it's going to be a 4. So for this, my GCF, my greatest common factor, is a 4. So that 4 goes outside parentheses. On the inside of parentheses, I put whatever we have left over. So we're going to factor a 4 out of 8, and that's going to give me a 2, and then my variable, so 2x. If I factor a 4 out of 12, that leaves me with a 3. So my GCF was 4, and then when I pull that out, whatever's remaining is the 2x plus the 3. If I want to check my work, I can do rainbows. 4 times 2x is 8x. 4 times 3 is 12. So it looks like I'm good. So for something that looks like this, factors of -4 would be 2 and 2, 1 and 4. Factors of -14 could be 1 and 14, and 2 and 7. So the biggest number that they have in common, it looks like, is a 2. So I'm going to put that outside my parentheses. So if I factor a 2 out of -4n, that's going to give me a -2n. Now be careful, don't forget your variable. Also don't forget that negative as well. If I factor a 2 out of -14, that's going to give me a -7. So that could be one possible answer. Or you could also see, oh, wait a minute, they have a negative in common as well. So you could actually pull that negative out and say that the GCF is a -2, and that's going to give me 2n plus 7 on the inside. Any of those would be okay. So the last thing, this one won't take very long. You might be asked to expand or simplify by distributing. That just means to do rainbows. The thing to remember is when you do rainbows, you're multiplying what's outside the parentheses to what's inside. So you're doing rainbows. Woo, rainbow. And you're multiplying. So 4 times c is 4c. 4 times 1 is 4. There you go. Okay, I'm going to stop there. If you have any questions, contact the teacher. Let us know through Canvas or email, and we'll be happy to help. Otherwise, may the 4th be with you.